Hi, I'm an old guy and I do maths, and today we're going to look at cubics coming to us in this form: a bracket x minus h, or cubed plus k. And my first task is to explain what all these letters mean. Those of you who've looked at quadratics and turning point form might find some of this quite familiar. Now, we're not looking at turning points in a cubic when we come to deal with this form, because to find the turning points in a cubic you need luck or calculus, one of the two. But what this does give us is the inflection point of a cubic. And I haven't heard it called inflection point form. Maybe somewhere it is referred to as such, but this is what all these letters mean. Now, first of all, this is a letter that is hopefully familiar to anyone dealing with polynomials. This is a dilation factor. It can be greater or less than 1. It can be positive or negative, and essentially what it acts as is a multiplier. So it can stretch out a polynomial when you graph it, or it can compress it. And again, those of you who've looked at quadratics would be familiar with that. These two things here, h and k, work in tandem, and we'll start with this first. What this does is it moves the cubic from a center point on the y-axis, left or right. So in this form with minus h, it would move it positive h along the x-axis away from the y-axis. If this were positive h, it would move it in a negative direction h units. And k moves the cubic up or down. So if we were to sort of draw this, what we'd have is a point of inflection for this cubic. This cubic is positive. We assume, we don't know whether that's negative or not, but we're going to assume that it's positive. And this point of inflection, which is here, and I make no guarantees as to whether this actually passes through the origin or not, but what we're interested in is the point of inflection. This is h, k, that point there. Now, if this were positive, so if I were to write this as a, again we're assuming a is positive, x plus h minus k, what I would have is I would have the following. So we would move from the y-axis h in this direction, and we would move down k. So this would be a value negative h, negative k, whatever that was. So sorry, that should just be a comma. So negative h, negative k, and let's say that the point is here, and a cubic would have a point of inflection there. Okay, so it's not turning point, but it's kind of an equivalent in cubic terms. Now, as part of this video, I thought that I would do a real example, so here is one. Let's get to work on this. Okay. So the cubic in question has got everything that it pretty much could have. It's got a dilation factor, it's got a number in here, and it's got a number here. And the first thing that we do is we go to work with these. And this tells us that our point of inflection is 1 unit to the right along the x-axis. So this tells us to move 1 in this direction. And this tells us to move 3 up from the x-axis. So our point of inflection here is 1, 3. Okay. Now, because we've got numbers, we can work out the other points of contact here. Okay, so let's get to work on that. So I've set this up just a little bit down here. So in order to find what the y-intercept is, we do the old familiar thing. We make x equals 0. And so what we get for that is we get 0 minus 1, which is negative 1. Negative 1 cubed is negative 1. 2 times negative 1 is 2. Negative 2, sorry. Negative 2 plus 3 is 1. So the y-intercept of this equation is 0, 1. So it's there. Okay, so what this thing does is it comes down here. This is the point of inflection here. And because y-intercept is above 0, our line passes through here, and it's a really strong clue that we're looking for an x-intercept in here somewhere, a negative number in here. And that's what we're going looking for here. So it is the old story. We make this expression equal to 0. So let's get to work on that. This is the slightly more awkward piece of work. Minus 1 cubed equals negative 3. X minus 1 cubed equals negative 3 on 2. Just make sure I get all of this in the frame. Now what I do is I take the third root of each of these, and I get x minus 1 equals the third root of negative 3 over 2. We can have the third root of a negative number, that's not a problem. We cannot have the even, well, we cannot have the even root of a negative number and expect that number to be real. Let me put it that way. But we can have the third root of a negative number without any bother. Unfortunately, I think we leave this as a surd. Our last step is this. We move the 1. So it becomes plus 1. And that is our point of intersection here. And so I'll just point an arrow up to that rather than try and rewrite that. So it is the third root of negative 3 on 2 plus 1. And I ran this through a calculator earlier just to see what it was as a decimal. I think it's a fairly small. I thought it was a fairly small number, and it is. It's negative 0.1447, allowing for rounding, I think. So it's a small number. It's negative, and it's just in here. And I think that this is a perfectly adequate way of describing it. This is an exact value here. Okay, so let's just recap quickly. This and this gave us our point of inflection here, which is the key piece of information here. Then we just resort to traditional techniques to find the x and y intercepts. We make x equals 0, we get the y-intercept. We make y equals 0, we eventually get the x-intercept. And that is everything mapped from here, and this is where we started, and that is how these work. Thanks very much for watching. See you next time.